Hi, everyone. Thank you so much for joining us today. We're excited to have you here for this live session on building data platforms in the AI era. This session is hosted by Steep, a metrics-first AI analytics platform that makes data accessible to everyone, and joined by Daana, a modern data platform company helping organizations build AI-ready data foundations. Our hosts today are Johan Baltzar, CEO of Steep, and Siavoush Mohammadi, CPO at Daana. In today's session, we'll explore what data platforms need to succeed in the AI era, why semantic clarity and governed metrics matter, and where real opportunities and challenges lie today. A couple of quick housekeeping things before we get started. Please note that all participants are muted during the session. If you have questions, please use the Q&A function at the bottom of your screen. We'll do our best to answer as many questions as possible during the session, and we'll have time for Q&A at the end. With that, I'll pass the controls over to our hosts so we can get started.
Hello and hi, Sia. So good to
Hi,
have you here.
happy to
Uh,
be here.
so I'm here, and thank you, Dorian, for the housekeeping. So I'm here with Sia Mohammadi, co-founder and CPO at Daana. Warm welcome. Uh, you have according to my notes here, you have a background in engineering physics, Sia, which is actually the same as I do, but I think you studied in Uppsala and I studied in Lund.
Yeah, exactly.
And you worked with data across consulting, insurance, telecom, and I saw you also worked with NASA, which I was like,
Yeah,
I have to learn more about this. Uh,
yeah. So I actually have a space physics background. I did research for a couple of years, and one of the people who was doing the PhD while I was there, he continued to NASA, and he was complaining about having difficulties doing his analytics on his simulation data. So, well, we helped him build a small data platform for it.
nice, exciting. Maybe a little bit of help to the recent Artemis mission here. Maybe helped out somewhere. Uh, cool. But you're also a repeat founder, and recently co-founder and CPO of Daana. And Daana, see if I get this right, declarative data engineering. I've also heard you guys be referred to as like a data platform as a service, which I found very intriguing. Uh, and I'm selfishly looking forward to this chat. So because I'm super curious to hear about your approach. We've discussed a little bit in the past, but I see this as an opportunity for myself to kind of like dig in a little bit deeper, since we kind of share the passion for semantic models, more kind of declarative approaches and AI friendly ways of working. So
Yeah.
I want to get into all of that, but first I wanted to start with just like asking, how did you get into data?
Like most people my age, I would say, just by chance. So after my research was winding down, I was kind of trying to figure out what to do with my life. This is roughly 16 years ago.
Mm.
And by chance, a recruiter called me for a consultancy gig, which had nothing to do with data whatsoever. I accepted and started working there. And my first assignment was I needed to code the functionality of a Java button. And I was instantly feeling tremendous regret. What have I done with my life? But just by chance, this small consultancy company had an opportunity with Tele2. They needed more. Back then, we were called ETL developers.
Mhm.
I had no idea what that was, but the sales guy decided that, well, you worked with data before when you were doing your research, right? Oh, so I'll send you in as an expert. And I kind of like, no, please don't do that. I don't even know what kind of like what this is about. But anyway, they did it, and I ended up in Tele2's old warehouse. and you suddenly kind of found a passion for it. And hey, this is amazing. This is very similar to the stuff I was doing before, just different type of data.
Mm.
So
Nice.
just by chance.
It's like a classic consulting thing. Like you have to become an expert really fast.
Yeah, exactly.
Nice. So you worked, I guess, like with all kinds of data platforms, big ones, data architectures, uh,
Yeah.
and I bet like companies like Tele2, I'm guessing they have a lot of data.
Oh yeah. Even back then, their biggest tables would be like 2 billion rows. And the particular machine that was running this, we benchmarked it later on. It was maybe comparable to a modern iPhone,
Mm,
the entire data platform.
mm,
So back then, if you would kind of like, if you want to do a fix on that table,
mm,
you would check everything 3 times because it would take roughly 24 hours to run.
mm. Uh, it's funny because I mean, I worked at a lot of tech companies, and I think a lot of us that are kind of like new to data, sometimes you think it's like a new field, but a lot of the practices are like we've been doing this since the 80s or the 90s. Some parts are very new, and then some kind of problems are really quite old.
Yeah, indeed they are. Uh, and a lot of the issues have been actually kind of getting more focused now with the kind of dawn of AI.
Mm,
Um, After kind of the big data boom, the most of our industry was kind of saying that, hey, we don't need to structure or model data anymore. We can just, dump it in the lake and
yeah,
it'll work out.
yeah. I know. I remember when I worked at Spotify back in the days, and I think the main challenge was just like big data, right? To your point, the scale, just like can we even manage it? So it felt like there was a lot of focus on the technical challenge and like going cloud and scaling up. So less focus on like cool, but how do we even like model the data or how do we kind of keep track of it? So uh, it's interesting now that I think like given AI and agentic work that suddenly like the structure, the modeling, the architecture suddenly becomes way more important again. Uh,
Exactly. I would
so
I would claim it always was important, but
yeah.
like the agents becomes very lost when they don't have context.
Mm. So you've done a bunch of different data platforms. You kind of jumped in and helped a lot of different companies kind of wrap their heads around their data and their data architecture. But what kind of led you to start something new?
So for all the data engineers in the audience, when you've done a couple of platforms, you'll start to notice a pattern. You step in, you try to understand the business side a little bit. You write bunch of boilerplate code essentially. Most of it is usually very similar to the previous one. So this repetition of things, I just kind of like started thinking there must be a better way to do this than write this from scratch each time.
Yeah.
So that was kind of the core idea. This was pre-AI even.
Mm,
That how can we kind of enable the data engineers to focus more on the business side and understanding,
mm,
and less on writing a little bit maybe even boring boilerplate type of code.
yeah. And I think that resonates a lot to me because we had the similar frustrations and challenges, but me kind of focusing more on the analytics and like how do you kind of get data out to the business? Because that's also been my experience of like setting this up kind of 3 times over in different companies. You start to recognize like we're doing the same thing over and over again, right? We're just like rebuilding, writing the same SQL, doing the same Python, and it's very cool. Like the first time you do it, you feel super smart and you're like, we're building something unique. But the third
Yeah,
time you just realize like, wait a minute, like how many companies are just like redoing the same thing and kind of creating their own mess over time.
Yeah, and then you also get into kind of like, yeah, I think most of us have been guilty of this at some point in time.
Mm.
You build this beautiful pipeline, you model the metrics really nicely, you build this wonderful dashboard, and somewhere down the line, few months later, you kind of notice that, oh, wait, this has been broken for a week now. Nobody has
Yeah.
reacted. And
Yeah.
you realize nobody's watching this.
So with Daana, you guys are taking kind of a wild new approach, I would say, I guess. Like it's less about like writing the SQL pipelines and stitching them together one by one. It's kind of a fundamentally different approach. It's declarative. It's the idea that we want to kind of model the data in a very different way than I think what many of us are used to, and kind of starting from that point to then like kind of generating, I guess, like finally the SQL or the code that actually gets executed. Um, and I'll let you kind of fill in here to kind of explain it better yourself. But that's
Yeah.
kind of like my view. But I think for many of us that have done data engineering or like done ETL for many times, I think we're kind of like everyone's used to using DBT, right? Everyone's used to writing SQL. That's kind of like
Yeah.
the standard of the business in the last 5 or 10 years. And I think for many of us, like, cool, but ETL and data engineering, yeah, it involves like you're extracting data from whatever source system you can get your hands on, right? And it comes in whatever shape or whatever quality that kind of like exists in those systems. And then we do our best to kind of like, clean it up, transform it, standardize it, kind of try to, wrangle it into some kind of internal data model shape, be it something Kimball-like, some star schema, facts and dims, or more of a medallion architecture. So, you know, why do you think another approach is needed here?
So a little bit kind of like when big data was introduced, a lot of good things were introduced. Software engineering practices were introduced,
Mm,
and this kind of got really well cemented with DBT, I would say. So they've done a tremendous job of kind of introducing good software engineering practices.
mm,
But during that same time, I think that some knowledge were, lost is a strong word, I would say, but kind of got down prioritized. And many reasons for people not modeling data was also because it felt hard to do and maintain.
yeah.
I, kind of a lot of the time you would kind of see that, yeah, we would like to, but every usually people would have kind of negative experiences also, kind of like I worked in that warehouse that had a I don't know, some sort of ensemble model data vault or something, and it was really hard to maintain.
Mm,
So kind of a core idea here is to merge the good stuff from those modeling techniques with the good stuff from modern data engineering practices. So
mm,
you want to keep the CI/CD thinking. You want to keep the versioning of stuff.
mm,
You want to have all of that because back in the days when you would want to make a change, you would log into the commonly shared root password
mm,
between all of the ETL developers, do the changes, and
mm,
in production,
mm,
which is not great. So but we want to make those modeling techniques accessible essentially to
mm.
people without forcing them to learn, spend months learning exactly how a particular flavor of Data Vault, for instance, works.
Yeah.
Because
Yeah.
though
I think no, I'm just I think I've done also a lot of like classic Kimball, classic star schema, just dabbled in Data Vault, but also always thought it was just like this feels like something you could do a PhD in, you know?
yeah, And you know, and you're right, and a lot of it is kind of our fault also. We who've been kind of excited about that type of modeling techniques, we've taken a very academic stance, I would say,
Yeah.
which has been kind of hard to get to resonate with the new data engineers that've been coming up.
Yeah.
So we share blame in that situation, I would say.
But I want to get into it a little bit, I guess, and like so tell us like what is the approach and how is it different? Can you kind of like yeah,
Yeah.
walk us through it?
So just kind of I wrote one blog article about this topic generally.
Mm.
And one comment I received was, "Hey, but SQL is declarative. What do you mean?"
Mm.
So that's why I thought that maybe it's worth, since we're talking about definitions and declare stuff, well, let's define what we mean.
Yeah.
So I'm obviously not meaning SQL, even though historians might claim that it was written as a declarative language. We're saying that instead of writing the code, you declare what you want it to be. Like what should the target shape be?
Yeah.
And if you have any transformations, do they look like?
Mm.
But you strip away all of the kind of boilerplate code that you need to handle. Like, for instance, how do you load this incrementally? How do you make sure that you have um, bitemporal stuff, or all of the tricky stuff that you always need to do more or less exactly the same way each time,
Yeah.
but is a little bit academic, to be honest, to wrap your head around. We want to remove that.
Yeah.
So we want to declare our intent instead, and give it a semantic definition in ideally all layers of the data platform.
Mm.
So that's the big difference here. So you let the system generate the pipelines instead of writing the actual transformations.
That's super interesting. And I know you talk about layers, so I would love to get into that as well, right? So there's, I mean, like classic ETL, right? It's or ELT, like extract, load, and transform. So I guess you're talking about some similar layers here, right?
Yeah, exactly. So I would kind of claim that most of the industry kind of agrees that we should have some separation of concerns
Yeah.
here. We should have, like, we use DBT talks about medallion architecture, and regardless of the name of these different layers, we kind of agree that there should be some sort of separation
Mm.
because they might have different purposes.
Yeah.
Like the language we use to describe each layer might sound a little bit boring because we spell it out.
Mm.
So from our perspective, the first layer should actually represent how the sources and the data generating systems look at data.
Yeah.
Like, we shouldn't do transformations at this level more than basic stuff, like flattening the data out. Like, if you receive just JSON blobs all over the place, it's really hard to do anything with it for a human or an AI. I mean,
Yeah.
so like data platforms like tabular structures. That's just the way it is.
Yeah.
So in the first, but you don't do any more advanced transformations. You don't start normalizing stuff, and you don't start renaming stuff heavily. You want to be as close to the source systems as possible.
Yeah.
That's the source system perspective, as data as the systems sees it.
Yeah.
The second layer I usually talk about is kind of data as the business sees it. Yeah, like, you might have three different CRM systems, but from a from a company perspective, we only talk about customers. We don't care really where they are living in what CRM system. And you might switch out one CRM system for another, but you don't want everything to break downstreams just because of that.
Yeah.
So the middle layer is really about understanding the business and the business processes and the words they're using at the coffee machine when they talk about their sales numbers. And kind of instead of it being loose understanding of kind of, yeah, everybody knows what we mean with sales. No, let's define what a sale is.
Yeah.
And the last layer is kind of more from a requirements perspective, because here we have more degrees of freedom, I would say, because a particular BI tool might prefer data in a particular structure. And if you're doing reverse ETL, for instance, and feeding back data to the CRM system, they might want data in a particular structure. So here we actually prepare everything for serving. And now in this picture here I've kind of merged two layers into one, and call it semantic layer. But you could also think about this as one physical layer, which might be Kimball model or something, and a semantic layer that would, for instance, live in Steep.
Yeah. No, exactly. And I think we share a passion for the semantic layer part, and we typically see that as like a thin layer of logical definitions, and typically like a star schema just below works really well, I think. So totally agree with that. But I really like this like structured approach. You're saying like, well, one thing is like, well, we should try to separate concerns, right? We need to do this in steps, and we should try not to like do transformations too early, or kind of like mix the problems up.
Yeah.
So you're saying like first, like we're getting data from the source system, it just comes in roughly as it is, right? So we're loading data from Salesforce or from Stripe or whatever, and we just do maybe some basic flattening out of things, but kind of
Yeah.
try to keep it as kind of as is, right?
Yeah, I historize it. Make sure that we have history, so that if we
Yeah.
change a definition in the subsequent layers,
Yeah.
you could always full refresh and get a new view of the same data.
Yeah. And then in the second step, then we're saying like, well, now we want to start kind of, separating the actual underlying source system and kind of like go at least one level up, right? In abstractions, we're saying like here's the CRM data, or like here's the payments data, I guess, right? And that could actually be different CRM systems underneath. Or is that correct?
Yeah, and even kind of one step further, I would say. So, like for instance, if you have an e-commerce situation, a customer would place an order. The order would contain order lines. This
Yeah.
is really describing a business process. So that's
Yeah.
what we're modeling here. And we're trying to use the words that the business naturally uses to limit friction. Because something that we need to think about also is that we really need to make sure that the language that we use in these models are anchored in the commercial side of the organization.
Yeah.
Because if I build something from my perspective, from a technical perspective, and everybody in the organization says, no, I'm not going to call this thing a user, I'm going to call it a profile. Well, then each time somebody uses the user entity in this picture, they will be confused.
Yeah.
Yeah.
And I would say, especially now this year, as everyone is kind of leaning more and more on agents, I guess what I'm seeing with my team, working of course with like developing our product, our platform, is that, in order to enable the agents, right, you need even more structure, even more like agreement on what do we call things, what
Yeah.
is an order, what is a customer, right?
And question to you, why do you think that is? What?
What, well, I think because we need to kind of guide the agents a little bit, right? They are smart and they are getting smarter. They have a lot of common knowledge, but then we want to kind of get them to do some useful stuff on our code bases, be that like, us writing the Steep platform in a big code base, or like a data platform, right?
Yeah.
So just like guiding them to like, what's what here, what's the learning about our little world that we're creating.
Ex- exactly. And a big difference here is that like at every company I've ever worked with or helped with,
Mm.
there is this one person, which is more or less the oracle.
Yeah.
Uh,
Yeah.
that's the person you ask, is sitting with tremendous amount of tribal knowledge, basically,
Yeah. Yeah.
and can know exactly that, yeah, if you look at this, no, that value in that table for that thing means this. I know in every other circumstance it means something else, but all
Yeah.
of this tribal knowledge, the LLMs don't have access to it.
Yeah.
So they don't have that context.
Yeah, exactly. We're going from the implicit knowledge to the explicit,
Yes,
right? It's like, how do
there
we
you
make this
go. Yeah,
as explicit as possible, right? Which is
yeah,
like a new new skill to learn. I think we all learn to not do any documentation because it was just a wasted effort, right? And no one would ever look
yeah,
at it. But now suddenly you're like, wait a minute, like we can get so much value if we
yeah,
can just like automate the boilerplate stuff, right? So we
yeah,
focus on declaring the important stuff, right? We're modeling, we're declaring, we're making stuff explicit. And then actually all the standard stuff, right? The things that we're doing. Yeah, this is a basic SQL query. This is a basic TypeScript function. Like no human needs to do that anymore, right?
yeah,
So I think that's like the big like fundamental shift that's going on. Also why I like this approach, right? Because this is not just like the structured into different layers. I mean, this is good, and this was true, I think, even before, right? Even 10 years ago, like
yes,
this would be a good
absolutely.
idea to do, right? For just to organize your humans, your team.
Exactly.
But
Organize your humans. Yes.
but now you're saying like you guys are taking this way further, right? So this is like let's declare like the for layer two here, like the data contracts, right?
Mm,
For layer three, like how actually putting this into YAML files, right? The model of the entities and the kind of concepts and the information. And then you're
exactly.
basically like, after that, we should be able to just push a button and kind of generate out all the code that's needed to
Right.
actually just do this, right?
And the important thing here is that, like, even if we take this approach and the YAML files or the declarations in whatever format one deems necessary
Yeah.
doesn't actually drive the implementation of how the code should be structured, that
Mm.
documentation will become really stale really fast. Yeah, I mean, for all of us who've been working in a cloud code project, you could spend a bunch of times creating these MD files, etc. And once in a while, you kind of do, wait, maybe I should review all of these MD files I've created. And then you suddenly see that, oh crap, half of it is not relevant anymore.
Yeah.
But what we're suggesting here is that generally for a data platform to be AI friendly, you know, the documentation and the implementation needs to be locked in. So the documentation needs to actually drive the implementation.
Yeah. Yeah, it's like the spec becomes the important part.
Yeah,
You're moving you know, maybe we don't need to maintain the actual code that much anymore. It's more like, but we really need to maintain like the spec or the underlying model, right? I want to also get into make this a little bit more kind of practical or visual. So maybe we can just take a quick look at like data contracts. Like what does that actually look like? And I think we might have a slide on that here.
yeah,
So this is basically uh, like a YAML spec, right?
yeah. So basically, I mean, there are when it comes to data contracts, there are open standards. There are also I know Robert Salin here in Stockholm has written a bunch of good stuff on this topic also.
Mhm.
Um, Here's an example. The important thing here isn't the exact format, but rather I just wanted to show you guys kind of like how would a data contract look like. So this
Yeah,
would be a specification on how to unpack the data that is coming in a raw format. And just to give a little bit context, like I'm not a big fan of schema inference on inside of ingestion pipelines because, the source system removes a column, adds a column, changes a column, and suddenly the ingestion pipeline itself breaks. So I'm a big fan of kind of proposing that, hey, do a really, really friendly ingestion that basically can't break, and then use a contract to unpack it. So writing the SQL code on how to kind of unpack this JSON blob or whatever format you guys think is necessary or good, uh, declare it instead.
Yeah.
And this could transform into DBT code or data form code or native SQL. It doesn't really matter.
Yeah. No, right. The spec, the contract is the important part.
Yes.
Do you also get into something I've had a discussion with recently with bunch of data leaders that we work with, is kind of like, because you can have like a contract on like the shape of the data, right? It's like, well, there are these columns and this is an ID and so on. Then there's almost like next level when you're like, yeah, but what's the quality in this column, right? Like this should contain, I don't know, category labels or whatever, but you know what? Sometimes they're null, or, we changed how we did the labels 2 years ago. And so it's almost like one level deeper when it comes into like what's actually inside the data, if you know.
Yeah. Yeah, I have a horror story regarding that. It was, I'm not going to mention the company, but we built a pretty big warehouse, and we were integrating to the CRM system, and suddenly all of our pipelines broke. And everybody all the way to the CEO level was screaming at the data team that, hey, I'm not getting on my reports, something is broken. We spent time and trying to figure out what, everything looks correct. Why is this breaking? Well, the CRM system had decided that the primary key should change meaning and structure and what it should contain, and didn't notify us.
Yeah. It's classic. It's like why data engineering is so hard, because like other engineering practices, like you can create your perfect world, right? There's like, we know what the inputs and the outputs are, we can test everything. And then, with data engineering, it's just like, we have to use whatever we get, and then try to like structure and bring some order to that.
Yeah, and this is why Anthropic released their article about their data platform, I think a week or two ago. And this is actually one of the main points they're pushing on why you actually need to model stuff, because it's much more, it's more difficult than software coding, where you can actually validate things in an easier way. Like I'm simplifying now, so if there's a software engineer in the crowd, and don't get pissed off now, but you can at least compile it and see if it works or not. But when it comes to data, everything can run smoothly, and not a single number is correct, or everything runs smoothly and suddenly you have a big query bill of $200 for accessing that table. So there are much more nuances to the ways things can get screwed up when it comes to data.
Yeah, and I think that's what you learn the hard way after in data engineering, right? But I also wanted to make sure we have time to get into just shortly, briefly about the information modeling here, which I think is super interesting. So here you have an example of that as well. That's another kind of like YAML spec as well, where you define the entities, I guess, and the relationship between the entities.
Yeah. So this middle layer is one of the hardest ones to build normally. And the reason is because you have to do a bunch of integration here. Well, when it comes to this layer, there are basically two parts of it. One, which is describing from a business perspective, what do we mean with things? What do we mean with subscription, account, a user, etc. That needs a clear definition. And we haven't talked about it that much yet, but I think you and most of the audience immediately see that, well, if we have these definitions in semantic in easy accessible files, then the LLMs will be able to get that context that might otherwise be hidden in tribal knowledge inside somebody's head.
Yeah.
So this is capturing on a model perspective, kind of like we're not saying anything here about how you map this model. But that's the other side of this. So one side is pure kind of understanding the business and modeling it. And the other side is, okay, so we have this beautiful model now. How do we map things to it? Like we have 3 CRM systems. How do we kind of get a single definition of a customer or a subscription?
Nice.
So, yeah.
So we model the data contracts, we ingest some data, we model the business, the entities, we push the button, and then we generate the whole data platform essentially.
Yeah, that's the beauty of this. Especially with AI agents, this becomes supercharged. The best example of this is when you have a declarative end-to-end stack like this, is that, for instance, if you get a new requirement of a new report, new metrics or something, if you just ask the agent, like, well, we need to build this new fact table, or we need to build this new report or this new metric. Since it has perfect context in terms of definitions and mappings, both in the middle layer and also in the first layer, it can itself understand, do we have a gap? Are we missing information to be able to do this calculation of this metric that is defined like this? If we have, what is the gap? Do we need to add something in the middle layer, for instance, a new attribute under subscription? Or do we have that data in the staging layer? If we don't have it in the staging layer, do we have it in a raw format somewhere hidden in these JSON blobs? And it can traverse the entire data platform. And I've done this with 2 clients recently. And it's a little bit like watching magic, because it kind of realizes that, oh crap, I'm missing some data to be able to drive this metric. Oh, it's not modeled in the middle layer. It's not available in the data contracts, but hey, look, it's available here in this JSON blob. So, okay, I need to update the data contract. I need to add it, model it into the information model, and boom, now you have the new fact table.
Yeah. And then you also generate the metric, right? In the semantic layer, and then you ship it out to the end users.
Yeah.
I mean, that's like a super powerful idea, being able to like really kind of thread the needle all the way and kind of like be able to, to inspect, to automate and to fix things going end to end. I think that's super powerful. Awesome. I want to make sure that time flies. I have so much to talk about, but I think maybe, Dorian, we should maybe actually head over to some Q&A.
Yeah, exactly. That's what I was just going to pipe in and say. We do have a few questions already, and feel free, if anybody has any more questions, feel free to pop them into the Q&A. So first one is, what are the biggest gaps between being AI ready and actually getting value from AI?
Yeah, that's a great question. Generally speaking, when is a data platform useful? When it provides insights to the end users, the people who are actually supposed to take decisions for the business, in a trusted and easy, frictionless way. So I think one of the mistakes we in data often do is that we focus too much on the technical and too little on our purpose. Our purpose is to serve the business.
Yeah.
So I think like talk to your data is actually a really cool thing. I mean, we've had this holy grail within data that we've been searching for most of our careers, like self-service BI. And talk to your data is the extension of that in my mind. And so for me, when you can talk to your data in an accurate way and actually trust the results that are coming out, that's where you're actually getting value from AI in a data context. That's one part of it. That's from the end stakeholder perspective. The other perspective here is that if the data platform is easy to navigate with an AI, like we've talked some, so we showed some YAML files here and declarations, and we understand that those are easy to navigate. I gave an example of how you should can do it. So the other part of this is how AI can assist in development and maintaining data platform without it being bogged down with kind of like being forced to scan through, I don't know, hundreds or if not thousands of, individual SQL files or SQL X files or DBT files to kind of guess its way into what this means.
Yeah.
We always have this auto compress also. So if it's too much code it's scanning through, then it will lose itself.
Yeah.
Awesome. Next question. What parts of the modern data stack are overhyped right now?
Ooh, sensitive question.
Without causing any enemies.
Go for it.
All right. So I think like generally speaking, again, in data, as long as I've been for the past 16 years, everybody's talking about kind of the silver bullet. So for a period of time, it was big data, and then it was these kind of, when the DBT came, we were talking about them as this new silver bullet that solves everything. And what I want to push against is that there is no silver bullet tool. This is data is very different from other types because it's you have to understand the business side of things. So what I think is generally overhyped is tooling. Like there are awesome tools out there, but if you use them wrong and if you put them together wrong, they will still not create value. Value is created from an end-to-end perspective when it works. So I would say kind of don't get fixated with a single tool. And we are two vendors here in this room, but still, I'm saying like you need to think about the entire end-to-end perspective here. Something that has been underhyped is the need for architecture, I would say. Fortunately, I think AI has, if you read, kind of followed Anthropic or OpenAI, something they all talk about is kind of like, writing the code isn't the big thing here. You should spend time designing and architecting stuff.
Yeah.
And that's extra true, I would say, for data platforms.
Yeah, I think we're coming out of an era where just writing SQL, just like putting out a lot of DBT models and writing SQL has been the main thing. And now we're like, well, like that's not what we're gonna do in the future. Like, why do we spend our brain cycles just generating SQL, right? No, it's more about the structure, the architecture, the modeling, actually understanding the business and how we can provide value to our organizations. I think that's where the next main focus will be.
100%.
Thank you so much. Just to be mindful of time, we'll answer one more question. And then if anybody has any further questions, feel free. We'll provide some contact information on the next slide for you to reach out. But last question for today. What would you prioritize over the next 12 months if you were leading a data team today?
I would build on experiments. Like, fortunately now, so the entire stack, there are tools out there that are more declarative first, or at least declaratively enabled. Try to build something. Try it out. Try to make sure that your ingestion process, we didn't talk about it that much, but is set up with Terraform instead of use a data contract to unpack the data. Model the middle layer in a way where, do an experiment end to end for a closed use case. So you don't need to like you don't need to kind of scrap everything you've done and build a big bang type of thing. You can just try this out end to end and then see the value that is created and build from that. That's what I would prioritize.
All right. Thank you so much, Sia. This was interesting. I think we could definitely talk for another hour. And thank you in the audience for listening in and for all your very good questions. Just to wrap up, Sia, if people want to know more, where can they find you?
On LinkedIn, on our website. I also have for each of these layers, we have a bunch of blog articles that kind of describe more in detail how you actually build stuff. If anybody's interested, I'd be happy to send them out. But LinkedIn, connect, and I'll be happy to talk.
Awesome, great. That's a good place to wrap. So thank you all, everyone. Thanks again, Sia, and hope to see you at the next event.
Yes,
Cheers.
thank you. Thank you for having me. Bye.